Hey guys, I don't know if anybody's watching right now, but in case you have any questions, please go ahead and type them in the chat below. I'm here to help. We are on Digital Agenda 325 and 326 at this point. And yeah, talk to me. I want to see how you guys are doing. I miss you guys. Please ask a question, something, somebody. Will, how's it going? You having any trouble with anything? Jorge, good to hear from you. Hello, hello, Jalissa. You guys, if you guys have questions, just type them in the chat. I will do my best to answer all the questions that you guys have. We're going to be on here until 1:30 p.m. today, and depending on how you guys like it, we can do more in the future. So go ahead, somebody, if you have any questions on any problems, tell me. I don't know how to do number one or number two. Does everyone here know how to do all the work? I hope so. What? I'm on my laptop. Okay, yeah, you guys, if you need to go through the documents, go through the digital agenda, we can start from the first digital agenda, or we can look at the one that I just assigned. I can take you guys how to do the do now step by step if you guys want to do that. Or we can start with the I did not just wake up. We can start with digital agenda 318. You guys let me know. There we go. Thank you, Leah. So everyone probably needs help. And we're going to start with the do now of 325 and 326. So everybody, maybe have that document out on another tab. I'm going to write down the question on my whiteboard, and we can take a look at the first one. It says rewrite exponents with correct notation. Now just give me a sec to write all this down. Okay, so let's look at the first question on the do now of Digital Agenda 325 and 326. So if we look at the question, it says rewrite each expression in a simpler form using exponents. Can everyone see this clearly? I hope no one's seeing this backwards. Can everyone see this? Well, first, I want you guys to realize and recognize what an exponent is in the first place. So when we use exponents, we are talking about representing how many times we multiply a number by itself. So for example, in this problem, on the do now, you have 4 times 4 times 5 times 5 times 5. How many times are we multiplying 4 by itself? And how many times are we multiplying 5 by itself? How could you write that using exponents? Can anyone answer those questions for me in the chat? Again, how many times are we multiplying 4 by itself? And how many times are we multiplying 5 by itself? Good, Will. So we multiply 4 by itself twice, and we multiply 5 by itself 3 times. So there's a way that we can rewrite that in a simpler version using exponents. You would just write it as this. You'd write it as 4 squared times 5 cubed. 4 squared is 4 times 4. 5 cubed is 5 times 5 times 5. Therefore, you can just rewrite the expression in a simpler way by saying 4 squared times 5 cubed. And cubed means raised to the 3rd power. So that's the answer for the first do now. And you guys, the CPM hints, they give you the answers, but I give you those answers so you guys can go back and, see how you solve for the problem given the answer, kind of like a reverse engineering type of thing. So again, the answer is 4 squared times 5 cubed for the first question on the do now, A. Let's look at B. Did that help? Did that explain that a little bit better to you guys? So B, they have 3 times 3 times 3 times 3 times 3. That's times y times y. Okay, in this one, how many times are they multiplying 3 by itself? And how many times are they multiplying y by itself? Anybody type it in? How many times are we multiplying 3 by itself? We have 3 times 3 times 3 times 3 times 3. That is how many times? Somebody type it in. Yeah, there we go, Jalissa. Exactly. So this is going to be 3 to the 5th power times y to the 2nd power. Yeah, no, 5. So it was 5 and 2. That was correct the first time. We're doing 3 to the 5th power times y to the 2nd power. And we got that because we do 3 times 3 times 3 times 3 times 3. That's 5 times. And then y times y is 2 times. That's why we can write it as 3 to the 5th times y squared. Let's get C. One second. Let me write this one down. So you have 6x times 6x times 6x times 6x. Okay, for this one, we have two terms. We have the number 6 and we have the variable x. In the problems we were doing before, you saw the numbers separated by group. In this problem, they aren't separated. They are 4 terms multiplied by each other. So what I can do is I can separate them, or I can just realize that it's the same term multiplied by itself 4 times. Meaning that is 6 times 6 times 6 times 6 times x times x times x times x. Okay? So we could write this answer down as 6x to the 4th. Let me rewrite this. We would get 6x to the 4th for this one. So when there are parentheses around a certain group of terms, everything within that parenthesis is part of the term. And if we multiply that term out 4 times, we'll just put whatever's in those parentheses and raise it to the 4th power. So in this case, they had 6x, and they had 6x in the parentheses, so they did 6x times 6x times 6x times 6x, and got 6x to the 4th. Is that clear to everyone? Can everyone see that? How when we have parentheses around a certain group of terms, we just take everything inside the parentheses and raise it to whichever exponent? I hope so. Let's move on to the second problem. I'm just looking at that, Giselle, and can I make a video on how to submit the Google Classroom work? Yes, I can. I noticed that a lot of you guys are having issues with that, so I'll try and do my best to make that clear for you guys. Let's move on to the second question for the digital agenda. Okay, so for this problem, it's similar to that first problem, and I feel like you guys might have a better understanding of how to do this on your own. But let's make a table. Joshua, we got to work for the answers here. We don't just, I'm not going to baby you guys, all right? One second, let me finish copying down this table. Almost done. And let's take a look. Okay, so they want us to write the original formed exponents into factored form and then to simplified exponent form. So here is our table. As you can see, we have the original form, the factored form, and the simplified exponent form. So if we have the exponent that is 5, hold on, let me fix that for you guys. That's a squared. That is 5 to the second power. So this is 5 to the second power times 5 to the fifth power. And that gives you 5 times 5 is your first term. And your second terms is 5 times 5 times 5 times 5 times 5. Does everyone see that? We had 5 to the second power times 5 to the fifth power. So if we write that in factored form, that's 5 times 5 as your first term, 5 to the second power, times 5 times 5 times 5 times 5 times 5, which is 5 to the fifth power. So if you multiply those together, that gets you 5 to the seventh power. Five to the seventh power, just like that. So what do you guys think? What do you guys think for the next ones? Before I move on and start writing the answers. How many times are we going to multiply 2 by itself on the next line? It is 2 to the second power times 2 to the fourth power. Honey, this is Digital Agenda. $325 and $326. So this is just the do now problems for the Digital Agenda 325 and 326. You guys still have to do the con problems and then submit the exit ticket. So you're going to do at least 3 problems from each con video. India, that's exactly right. We get 2 to the power 6th because we have 2 times 2 times 2 times 2 times 2 times 2. Good job. Just like that. Okay, Michaela, I'm going to go live again probably on Thursday or Friday for a longer amount of time because today I have a meeting at 1:30. So we're on here for 25 more minutes, and I'm going to help you guys again on Friday, and I'll be on there as long as you guys need me to. Probably a few hours if that's okay for you guys. Let's try and keep pushing forward on this though. So the next problem is 3 to the 7th power times 3 to the 2nd power. So if it's 3 to the 2nd power times 3 to the 7th, how many times are we multiplying 3 by itself? Can anyone tell me? Can anyone type in the chat room how many times we're multiplying 3 by itself if it is 3 to the 7th power times 3 to the 2nd power? Again, that's 3 to the 7th times 3 to the 2nd. In total, how many times are we going to do multiplication 9 times. Does everyone else see that? How it's 9 times? That's exactly right. So you do, in the first parentheses, it's 3 times 3 times 3 times 3 times 3. 7 times 3 times 3 twice. Okay, for anyone that needs help on the past agendas, we're going to go back to them on Friday. I'm going to go live again on Friday, and then I'm going to go over everything else just because I have a meeting today at 1:30, so I have to leave at 1:30. So it's going to be, we have 20 minutes left. But on Friday, I can help you guys with the old work. Today, we're just going to get through today's agenda. But does everyone see how we got 3 to the 9th power? This is 3 times 3 times 3 times 3 times 3 times 3 times 3. 7 times. Joshua, you as well. All right, cool. How about the last one? X to the 3rd power times x to the 5th power. Eight times, exactly. Because can anyone type it out that many times in the chat for me? Yes, our next lesson is also about exponents. So this lesson and the next one is about exponents. The last 3 lessons that we've done were about slope and the equations of lines. So I realized a lot of you guys had issues with those with the previous lessons. So I'm going to go live again on Friday to explain that. Exactly, Catherine, exactly. So you see how you do that? 1, 2, 3, 4, 5, 6, 7, 8. Exactly. Math over chat. How's that? How about that? Okay, so those are the first 2 do nows. I'll put it back up one more time just in case you guys didn't get it. But now let's move on to the classwork. Okay, so in your agendas, you'll see the language support, and it says for you to take notes. So this graphic image shows you all of the exponent rules. There is 3 that I want to go over today. We're going to do the product rule, which we just practiced in the do now. There is, let's just go over the first one. Product rule is a to the x times a to the y is the same thing as a to the x plus y. So if you have a squared times a to the 6th, this is a to the 8th. Okay, so for the product rule for exponents, as long as you have the same base, when you multiply 2 terms with the same base and they have exponents, you do addition of the exponents to get your final answer. So as you can see in the example below, I have a squared times a to the 6th. Those have the same bases, and therefore we can apply the product rule, which means we just add the exponents. So a to the 6th times a squared is a to the 8th, because 6 plus 2 is 8. This is just the explanation. These aren't questions that you guys have to copy down. This is just explaining the product rule. And now we're going to do the quotient rule, which is division. So if you have sorry, one second. Okay, so if you're doing division of terms with the same bases and exponents, you subtract the exponents, meaning that if you have a to the 7th divided by a to the 3rd power, you get a to the 4th power. 7 minus 3 is 4, so you get a to the 4th. I hope that makes sense to everybody. India, as if I understand your question correctly, the rule applies to all terms that have the same bases. So for example, if we had 3 to the 5th power times 3 to the 5th power, we add those exponents, so we'll get 3 to the 10th power. But if we're doing division, and I have something like 10 to the 5th power divided by 10 to the 3rd power, I'm going to get 10 to the 2nd power. So this is the rule when it's division. When we're doing multiplication, it's addition between those exponents. I'm glad you guys are getting help. I really appreciate it. The classwork. Okay, so the classwork now is for you guys to go watch the Khan Academy video where he's going to explain it to you again. Everything that we've been going over, he will explain in a quicker, more direct way. This is more of a discussion where I want to have you guys ask me questions. So again, the Khan video will help you understand the properties of exponents. And then I want you guys to do 4 problems from each of the lessons that I listed. And then you can attempt the exit ticket. Yeah, I'm going to give you guys here. So let's do some practice problems. How about that? What would x to the 4th times x to the 6th be? And what would x to the 6th divided by x to the 4th be? Here's just an explanation problem. So on the top, we have x to the 4th times x to the 6th. On the bottom, we have x to the 6th divided by x to the 4th. Can anyone tell me my answers? What would I get for the first problem? X to the 4th times x to the 6th. Can you type out the answer, or can you tell me what the exponent should be if it's x to the 4th times x to the 6th? Exactly. So what rule did you use to do that? Was it the product rule or the quotient rule? Aaliyah, these problems are just to help you understand it. They're not going to be part of the grade. So the graded work is do nows 1 and 2 and the Khan video classwork. Product rule, exactly. So you get x to the 10th. What would it be for the bottom problem where we have x to the 6th divided by x to the 4th? What would that be? Good job, India. Good job, Melanie. So again, you guys, what would x to the 6th divided by x to the 4th be? Are we adding or subtracting? X squared, exactly. The questions that you guys have to answer on your own are the ones from Khan Academy. I put the links in the digital agenda. The problems I just did right now in the blue marker, those are just explanation problems, just to help you guys. As of now, we've gone through the digital agenda. Would you guys want me to do a preview of the exit ticket? Let me pull it up. Sorry about that. Okay. I'm pulling up the exit ticket right now. Give me a second. Okay, let me write these down. I have it up. Let's look at the first one. Alrighty. So the first problem is which value is equivalent to 3 to the 6th power, all raised to the 3rd power. So this one is good because you guys haven't seen this one yet. This is called the product rule. This is called the product rule. Ready? Okay. For the product rule, you have a term inside of parentheses with the exponent. So if you have something like a to the x inside of the parentheses, and on the outside of the parentheses, it is raised to another power, you're going to do a multiplication between those two exponents. So for example, in our parentheses, we have a to the 3rd power all raised to the 4th power. So the product rule tells me that I'm going to do multiplication between the two exponents. So my answer is a to the 12th. Okay, that's only when you have the product rule and you see these expressions in parentheses where you have, a term raised to the exponent in the parentheses. On the outside of the parentheses, it's raised to the exponent again. So exactly, it's 3 to the 18th power because 6 times 3 is 18. So on problem 1 for the exit ticket, the value should be one that is equal to 3 to the 18th. Good. So that's number 1. Number 1, you utilize the product rule. Let's look at number 2. So number 2, they say which value is equivalent to 4 to the negative third. This one is also one that you guys haven't seen before. This one utilizes the negative rule. Technically, this stuff is review, so you guys should remember it, but I'm assuming you guys forgot. So the negative rule states that when you have a base value raised to the negative exponent, you rewrite that as 1 over a to the x, where your exponent becomes positive. So anytime you have a negative exponent, you drop it down to the denominator over 1. So an example would be if you have a to the negative 4, you would rewrite that as 1 over a to the 4th. Does everyone see that? The negative rule? So again, the negative rule is when you have a negative exponent. When your value is raised to a negative exponent, you rewrite that as 1 divided by whatever that expression is, right? But now it has a positive exponent. So example, you have a to the negative third. You rewrite that as 1 over a to the positive 3. Does everyone see that? So in our example, or in the exit ticket problem, they give us 4 to the negative third. So we're going to rewrite that as this. So India, it's not negative 64, but it does use 64. So let's look at this. We have 4 to the negative 3 is 1 over 4 cubed, which is 1 over 64. Exactly. So when you look at number 2 on the exit ticket, it utilizes that exponent rule, right? The negative exponent rule by dropping down 4 to the negative third in the denominator. So now you get 1 over 4 to the third power. 4 to the third power means you multiply 4 by itself 3 times. So you get 1 over 64 as your answer for question 2. I'll leave that up for a second, and then I'm going to erase it. Let's look at question 3. Wow, this timing is perfect. I have to be out of here at 1:30, and it's 1:25. I hope you guys are all doing good. I know this situation is very different now that we're doing online classes, but hey, we're all learning at the same time. So I'm really glad you guys are participating. I want to make sure that you guys are understanding this classwork and all the homework because I know it can be challenging. But with that being said, let's look at question 3. So they give us the problem 7 to the 5th times 7 to x is 7 to the 15th. Okay. All right, guys, which value of x or what value of x would make this expression true? You have 7 to the 5th power times 7 to the x power is equal to 7 to the 15th. So there is an exponent that will make this expression true. What value of x will make that true? And tell me what rule you used and why you know that. So good. You guys, the ones for everyone that's saying 3, that's a common error because we're using the product rule. And when we do multiplication between 2 values with the same bases, all you do is you add their exponents. I'm going to give you guys an example of where x equals 3 would be the right answer. Yeah, x equals 10 is the correct answer. 10 plus 5 is 15, therefore x equals 10. But here, let's look at an example where x equals 3 would be the right answer, okay? We would use the power rule in this case. So in the blue below, you have 7 to the 5th inside the parentheses. And on the outside, you have a parentheses with raised to the x power. So if that value of x was equal to 3, 5 times 3 is 15. So the exit ticket problem, it's okay, guys. I can be late. I'll be late for you guys. Does everyone see the difference for their 2 problems? For the 2 problems? The one in purple utilizes the product rule, and the one in the bottom uses the power rule. Right? The product rule is when you add the exponents and they have the same base, and the power rule is when you have a value inside of the parentheses raised to another set of exponents. Yep. And last one, before I have to head out of here. Okay, so in this one, they give you 4 to the 4th power divided by 4 to the 3rd power. So what is, in number 4, you're dividing. So when you divide, what do you guys do to the exponents? Do you add, subtract, or multiply? It's on the, remember the rule is on the digital agenda. All the rules are there. They're in the Khan Academy videos. But when you do division of exponents, you do subtraction. So 4 to the 4th divided by 4 to the 3rd. Our exponents are 4 and 3. So 4 is on the top. That means you can do 4 minus 3 is 1. And that was question 4. Yep. Okay, so I think good turnout. We had a good turnout today, so let's do Friday at 1 or 11 p.m. or 1 in the afternoon or 11 in the morning. Would you guys rather do another live video at 11 in the morning on Friday or 1 in the afternoon on Friday? 1 p.m. Okay. Okay, 1 p.m. it is. Thank you guys for tuning in. I will see you guys then. Great job for everyone. This is going to stay on the YouTube page, so it'll help you, if you need to go back and catch some notes. All right, everybody, have a good day. Rewatch the video if you missed any answers. They'll all be here.